first 5 or 6 with you at the bathroom. Charlie?
No, for number 4.
4 to 1 or 4 to 1? 4 over 1. Questions over answers. That's where we're at right now.
I got for number 15, I got 10 to the 9th power. Is that okay?
I don't have number 15 in front of me. It could be. I don't know. I don't know what does 15 ask you? Yes, that would probably be the same thing. Alright, who asked me one? Somebody back there asked me the question. What was it, Alex? Which one?
Number 6.
Number 6. Number 6. Let's see what happens here. A tile installer charges $12 per square foot to install a tile. What is the cost to install the room of this room shown here? No, all that. Wow. There it is. Just like magic, kids. Okay, the deal is this. They're asking you to find the area of this. And whatever the area is, you have to pay $12 per square foot. Okay, you need to find the area because that's square foot. And then for every square foot, you have to multiply by $12. That's what they're telling you. And that's kind of how carpet works, or floor tiles, or whatever it is. You pay so much per piece, so much. So in order to find the area of this, since we don't have a formula that finds the area of whatever shape that is, you have to cut it into pieces. And it's up to you. Did you cut it in pieces?
Well, no, I added 2 to the 4 feet and to make a box.
Okay, so you did this?
Yeah.
Okay, that's another way to do it. You could pretend like this is all one big rectangle, which would be 8 times 6. If it's a big rectangle, it would be 48 feet squared, but then you have to subtract the missing piece.
Yeah.
You subtract the missing piece, which is 2 by 4, 8. Take 8 away from that 48, you still should get 40 feet squared, and then multiply that by 12, it's $480. That was the answer. If you didn't do it that way, that's fine. You could do this, ignore this whole thing, cut it either like this or like this, it'll still be the same thing. But you have to remember when you do that, that if you're finding the area of this rectangle here, you can't use 6 because 6 goes all the way to the top. You have to use the 4 times the 8, which is 32. And then you have to do the 4 times this part, which is 2. And again, 32 plus 4 still gives you 40 feet squared. Or if you cut it like this, it'd be 24 plus 16. Either way, it's going to work no matter what. The beauty of math, more than one way to get home, it's up to you as long as you know what you're doing. Now, if you have a question on page 1, I'd prefer you keep it on page 1 so I can do all the page 1s before I have to go to page 2 and redo all this stuff. Any other questions on page 1? Caroline. And again, I encourage you to have a piece of paper jotting down notes to yourselves. Again, looking at your grades, there's not very many of you that I don't think that this could help you with. Sorry, Caroline, but I want to get that out there before you. Yes, which one?
10.
Problem number 10. So, I mean, certainly for problem number 1, I would wrote a note to myself that says, don't forget to multiply by whatever that number is up there, because problem with problem number 6 is that you get so wrapped up in doing the area, you get an answer for area, and then you forget about multiplying by 12. Did that happen to anybody? All right. So again, that would be my note for problem number 6, is that don't forget to finish up with that. Caroline, I am going to answer your question one of these days. Number 10. 10 doesn't happen to be on this page. Are you going to make me go to the page?
No.
All right, Caroline.
Okay.
Man, that gets big awful fast. Number 10 says to do this. It says, what is the area of a triangle with vertices of 1, -1, blah, 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 blah. And again, you are given a piece of test paper that has squares on it. Use it. Use that to do your coordinate system. I'm just going to do it here because, well, I'm just that good. So here are your coordinates. 1, -1, -1 is right here. 3, -1, 1, 2, 3, -1 is right there. And 2, 2, 1, 2, 1, 2 is right here. you end up with a triangle that looks like such. Now the notes I would write to myself would be these. First of all, the area of a triangle is 1/2 base times height. Okay, if you forgot to cut your triangle in half, then you're issues there. You don't want to really spend your time counting squares, you want to use this formula. The problem we have with this is, you know that base and the height have to do what? Form a square corner, and none of these lines form square corners. So, oh no, what do I do? Okay. Dave has a great idea. From the apex here, from the top point, just drop a line straight down because you have, that will give you a square corner. And you know how high that is because it's 1, 2, 3 units high. And you know that this is 1, 2, 3, 4 units wide because you can count those squares. So your triangle is going to be 1/2 of 3 times 4. Half of 12 will give you 6 units squared. Question on this one? What's that?
Does it matter if you have the line on the outside of the triangle or the inside?
No, if you wanted to do this and go straight down, that's fine. It doesn't matter where you get your, you can come over here and do it, drop it straight down there, whatever, but however you want to do it. But you've got nice pieces of square on your paper. I mean, you want to use those.
Could you actually do another one?
You back on the other page. We have a question on the second page while I'm just sitting here. I'll get back to them.
Okay.
Just because then I have to go back, click it, save it, redo it, whatever there. Kendall,
17, please.
number 17. So there'd be my notes on that one. Sure, 17. Guess what my note to, who can read my mind? What would be my note to myself on problem 17, Taylor?
Multiply first.
Order of operations. You need to multiply first. Can we not multiply first? There you go. You are, right now, Kendall, you are going to get another problem right simply because you wrote yourself that note. You need to, order of operations say you have to multiply first. You multiply this, it is 1/12. And you are adding 1/2 to that, or adding that to 1/2. Doesn't matter with addition. Common denominator of 12. This stays 1/12 times 6 times 6. 6/12, and 1/12 is 7/12. Out.
Did you do number 12?
I hope so. Convert 5, 6 to a decimal with the bar over the repeater. Can I tell you that generally speaking, I'll let you take your little reference piece of paper and just write down that thing. Isn't that one of our notes? Isn't it on there?
Yeah.
Now, let's say you don't have your reference sheet there. How would you do it? Well, this is a division problem. It's 6 into 5. Make sure you take the bottom into the top. And when you do that, it's going to look like this. 6 goes into 58 times, which is 48. 6 goes into 20 times, which is 3. And once you start getting the same number, you know that this number, the 3 is just going to keep repeating. So there is your answer. But I'm pretty sure that's part of the reference piece of paper I gave you. So take the easy way when I give it to you, kids. Sure. Should be out as long as it's like, is it on the outside of your folder somewhere? Or somewhere where it's, yeah, that's fine. Kyle?
18.
Now we're getting somewhere, kids. 18. Note to self on 18, Kyle, what do you suppose I'm going to say? There you go. No, that's kind of wrong, actually. Yeah. Again, I told you, a fraction line is a grouping symbol. And with that, you want to do this top first. Do the top first, then divide. There are other ways to do this, but you got to know a little bit about math in order to be able to do it. You don't know that yet. So when you line up the decimal there, Kyle, 1.2 plus 0.36, you're going to get 1.56 on top. Then, dear sir, once you get that, then you divide the bottom into the top. And that leaves up a whole new can of worms. When I divide that out, what has to happen? Exactly. I can have a decimal under here, but I can't have a decimal out here, so I need to move that 2 places, so that becomes a 6. I have to move this 2 places, and it goes straight up from there in my answer. 6 goes into 15 twice, and 6 goes into 36 6 times. So your answer should be 26. Math is not hard. Yes, Josh? Did you want the answer to something?
Well, no, but, can you do 20 on the board?
I would love to do 20. That's what I'm here for. You believe that, don't you? That's what I'm here for. Again, number 20, there's a bunch of different ways to do number 20. I don't know, it depends on how your mind thinks here. Okay. The first logical thing is somebody says, when you multiply x to the third times x to the fourth, you should get x to the 12th because you're multiplying. That's not the case. You have to think about what this means. X to the third power means you have 3 x's times themselves. X to the fourth power means you have 4 x's times themselves. So in reality on top you have x to the 7th power because that's how many x's you have. But rather than mess around with that, let's leave that like that. What does x to the 5th mean? You have 5 x's times themselves. Well, what happens when you have the same thing on top as on bottom? They will cross out 1 for 1. This x, that x, this x, that x, this x, that x, this x, that x, this x, that x. All of my bottom ones crossed off. What am I left with on top? X to the 2nd power. Now, if that seems a little primitive to you, we came up with rules for this. And the rule was this. When you multiply like bases that have exponents, what do you do with the exponents? You simply add them together. And when you divide like bases with exponents, you subtract the 2. So 7 minus 5 is x squared. So whichever way works for you. Tailpadium.
Can you do number 8?
18 or 8?
8.
Is anybody else on my page number 2?
Or number 19. I need number 19.
Let's do number 19. Guess what my note for myself at number 19 would be? There'd be 2 of them. I would jot for myself. Morgan, one of them would say,
Anything to the 0 power equals 1.
so you can read my mind. Anything to 0 power is 1. So right away, I would change this to a 1. Anybody out there not change that to a 1 or make it a 5? See, there you go. Right away, kids. See, now you've already gotten yourself 1 better. And then the second note to self is, once again, Sam, to order of ops. You must do multiplication and division before addition and subtraction. So that means I have to do this first. I have the 1 plus the 4 minus 3 times 2, which is 6, plus 1. And in order of operations, addition and subtraction fall on the same level. And when that comes, you have to work from left to right, just like you read it. 1 plus 4 is 5. 5 minus 6 is a negative 1. And a negative 1 plus 1 is zilch. I hope I got that right, did I? Not always do right. Taylor, you look perplexed. Give that to me again. 5 minus 6, 1 in the whole. 1 in the whole plus 1 gives you nothing.
Oh, okay. Okay, I got it now.
All in terms of money. Kyle?
16.
Oh, look, okay. Solve by inspection, which is a good thing because 16. Here's what I would do. Okay. this is the deal. You know that something, Kyle, divided by 3 has to give you 4. What does this, let's say this wasn't here. What number goes up top there? What number divided by 3 is 4? 8 divided by 3 doesn't work out even. Now, what? 12. So you know the top of this has to be a 12. Well, the top isn't a 12 because the top says what? T plus 2, I hope? Okay. You know that T plus 2 has to be 12 because that's the only number that goes there. So what number when you add 2 to it gives you 12? 10. Again, the solve by inspection ones you really should be able to do in your head if you think about it enough. Soon we'll get to a day when I'll tell you you can't do that, but they like to get you thinking about the process. Kendall, how?
For number 19, when it gets to the left to right subtraction and addition, I did 1 plus 4 equals 5, and then 6 plus 1 equals 7, and then I subtracted 5.
Wait, stop there. You did what? 1 plus what?
I did 1 plus 4 equals 5, and then 6 plus 1.
Nope, can't do it. That was what I just said. You have to work. Addition and subtraction fall on the same level. You don't do addition before subtraction or subtraction before addition. When you're given all those choices, you have to do it from left to right. Okay, if I end up with 5 minus 6 plus 1, I can't do 6 plus 1 first. You have to start at the left and work your way right. So you have to do 5 minus 6 first. Otherwise, you will get the wrong answer, guaranteed. 5 minus 6 is a negative 1, and then negative 1 plus 1 is 0. Okay. Addition, same thing with multiplication and division. They have to be done when they're your only choices left. You have to do those from left to right. Kyle,
You do 6.
are we done on this page?
Ready?
Did I already do 6? I always love it when that happens.
Can you do it now?
I already did 6.
I don't have to say 1.
Yeah, I did 6. Number 1. Oh, 1 is a good one, actually. That boy just gets really big really fast. Wow. Oh, I got a quick question on the screen. That's probably good. Okay, that's not a bad size right there. All right, the minute hand of a clock turns 6 degrees every minute. That simply means this. If you sketch yourself a picture here, here's your 12. Every minute, it starts out here, every minute, when you get to this, not to the 1, but to this line right after that thing, every minute is 6 degrees. Okay, so to go, how many minutes are there between 12 and 1 here? 5 minutes between the 12 and the 1. So it's going to move 6 degrees. So how many degrees is it between 12 and 1? If each one's 6 degrees and there's 5 movements there,
30.
it's 30 degrees for every 5 minutes. Well, it said to go to 2, I believe. So it's going to actually go 10 times, 10 minutes. So if 30 degrees is 5, then double that, 60 degrees for 10. If you went 15 minutes, it's obviously, it makes a right angle, so it's 90 degrees. If it went from 12 all the way down here to 6, it's a straight angle. How many degrees is a straight angle? 180. Every minute is 6 degrees. That's a good thing to know. It comes up quite frequently. If it only went 3 minutes, it's 18 degrees. Bailey?
7.
Yes.
Oh. Wait, but what was the answer to that?
This one was 60, wasn't it?
You said it was 1.
Oh, I didn't finish the problem for number 6, and there's the note I'd answered to myself. Okay. It asked what fraction. Make sure you answer the question for problem number 1. It said what fraction of a full 360 turn. So it went 60 out of a full 360. Sorry about that. I myself fall on mine. And then reduce that. It's 1/6. Cut off the zeros. it's 1/6 of a full term. Okay, I'm sorry about that. I would maybe got that one wrong. I got so excited about it. Somebody said which one? At $32 per hour, how much would a worker earn on a 2.5 hour job? Well, you can do it a couple different ways, Bailey. Let's just say, in 1 hour you made how much, Bailey?
32.
In 2 hours you would make double that. 32 is $64.
Yes, sorry.
If you make $32 in an hour, half of an hour is how much? Half of 32 is 16. So you'd end up making 64 plus 16, which is $80. But a simpler way just to say it is you're multiplying 2 1/2 times 32. 32 over 1 times 2 1/2 is 32 over 1 times 5 halves. 5 times 32 is 160, and cut that in half, you get $80. Just a matter of multiplying. And you wouldn't have to multiply if you wanted to do it in a chart form. In such sweet sound. Yes, Taylor?
Meeting number 8 now.
Oh, yes, I can do number 8. My notes for number 8, Holly, are the Pythagorean theorem. It asks you for the perimeter of this, and you only know 2 of the 3 measurements, so somehow, you can't just guess, somehow you have to figure out that third one, and you hope that there's a 5, 12 something triple up here, because that means you don't have to do any work. Zach, you're laughing because what, did I do something wrong? 5, 12, the hypotenuse has to be 13. You don't have to do any work but that. You've got this here, you've got the other thing in your notes. So it's just a matter of adding those together. 13, 12, and 5. Looks like 30 to me. Jawohl. In my best German. Yes, Kendall Houck?
For like a Pythagorean theorem, if there isn't like those numbers that we have the hypotenuse or whatever.
Well, if this didn't work out, what would be the next thing I would tell you to do? Look to see if you can reduce it to get a base triangle that is this. If you can't do that, then you actually have to do the work of that thing, which means you'd have to take 5 squared plus 12 squared, and that equals some number squared. They're not going to make you do that, I don't think, yet. You will get to that point. But right now, they're pretty nice to you. They make them nice little triples. It works out pretty evenly. They're very nice to you just because they don't want to. Eventually, we will have to do that. Kyle?
Was 90.
The triangle is a right triangle. It is also, well, none of the sides are equal, so it's going to be scalene. We don't have such a thing as a left triangle. It's certainly not equilateral because none of the sides are equal, and it's certainly not isosceles because isosceles means 2 sides are equal. Kendall Powell. Most of the time. What is the total price of 3.2 pounds of apples at 80 cents per pound? What did you get, pray tell?
$3.
$3. Can I ask how you got that?
I did 3 times 80, and then equals $2.10 plus 3 cents.
Where does 20 cents come from? You are just multiplying this together, okay? But the one thing you have to remember is this has a decimal and this does not. So if you multiply together, you're going to get how many cents, not how many dollars. Okay? 3.2 times 80, bring down to 0. 8 times 2 is 16, 24, 25. Okay? With a decimal here. would I accept 256 cents? Negative, you'd wanna change that into dollars, which means it is $2.56. You might wanna make 80 cents into a decimal, and that way your decimal gets there automatically, but $2.56. Kendall, I have no idea where 20 cents comes from, your $2.40 plus 20 cents.
I did it as a point two.
Huh?
As a point two.
I don't know what a 0.2 is.
That point two line three.
Right, but the 0.2 needs to get multiplied by the 80 cents too. You can't just say that's 20 extra cents. Because that's how many pounds, that's not how much dollars. Charlie? So the note to myself, Kendall, is I would change this to a decimal and then multiply the two together. Charlie?
I did 3.2 times 0.8.
Same thing, you'll get the same answer. Now see, here, 3.2 times 0.8, Charlie? 8 times 2 is 16, 3 times 4 is 25, 2 decimal places, $2.56.
I got
You're fine with that. Matter of fact, I'd encourage you, you don't need that zero there, it makes it easier to out it.
I got $2.
I can't change your multiplication methods. Josh?
What was 16?
Well, I did number 6, it was $480. What do you have?
I did it the way you did it, I think. Pretty sure I did, and I got 500 like 76.
What'd you get for the area of that shape?
48.
Huh?
48.
How does one get 48 for that?
Because I did the thing where you make it a big rectangle.
Right, and 48 includes this, because 6 times 8 is 48, but you need to subtract that. The piece isn't there, so you gotta take that away. Did you take that away?
Oh, that's right.
That is 2 times 4. You have to take 8 away from that. Kendall?
How is number 4 not 11 fourths?
Well, during the morning commute, 96 cars and 24 trucks pass through the intersection. What's the ratio of cars to trucks? Order is important. First one has to go on top. Second one has to go on the bottom. If I do that, how many cars were there? 96 cars over how many trucks? 24. That's my ratio, it just needs to be reduced. You can keep ratios as improper fractions, but they need to be reduced. What number goes into these two? Well, let's cut them in half first. 48 over 12. What number goes that? Cut them in half again. 24 over 6. Cut them in half again. 12 over 3. 3 goes into both of them. 4 over 1. You can leave it as 4 to 1 or as 4 to 1. That would be fine. I prefer the fraction probably. Would I accept just the number 4? No, because the number 4 is not a ratio. The number 4 is 4. You have to say 4 to everything. Boy, do I feel good about this test tomorrow. Extra credit might not be such a bad idea. Alex?
Do you know Mandarin Chinese?
I know. Who is she?
No, Mandarin Chinese.
No, I don't. There's a reason I should know Mandarin Chinese, the language.
It's the most common language in all the world. Really? Yeah.
If I had a nickel for everybody that told me that.
You would
I
be
know-
that sense.
I